All right, math students, we are continuing our section on transformations. So the learning target is still the same. I can perform transformations of functions. So yesterday we talked about what's called the translation. So moving that parent function left, right, up, and down. So we did a little discovery with absolute value. We drew the parent function for absolute value. And then we typed into our calculator to see what kind of movement that the different translations did. So now we're going to look at some transformations. So it's actually changing that parent function shape. Instead of just moving it right, left, up, and down, it's either going to stretch it, or compress it, or reflect it. So I think we did this last time, but let's just review here. Investigate what happens when you multiply by 2 outside of the absolute value. So let's type that in. Hit graph here. And you can see that the graph stretched up. It became skinnier. So this is called a stretch. And it's by 2. Then let's try the 1/2. Just type that in and see what happens. And you can see it became wider, it compressed. So this is a compression by 1/2. And then finally, what happens when you put a negative in front? Type that in. And you see that it reflects it, or it flips it over the x-axis. Okay, so let's finish up our notes over here. So when the absolute value of A is greater than 1, so like in this case we had a 2 here that's greater than 1, that is a stretch. And when it's less than 1, like we had 1/2 here, that is a compression. So typically the stretch will have a whole number, and then the compression will have a fraction. But be careful with these fractions. These fractions have to be less than 1. So let me tell you, just give you an example here. So like 1/2 or 2/3, those are all less than 1. But if you had something like 7/5, that would be greater than 1, because 7/5 is a mixed number if you simplify it. Okay, this is actually 1.4, so that's greater than 1. So be careful with this trick that it's a fraction, it's a compression, but make sure that fraction is less than 1 and not something like 7/5. All right, and then lastly, if it's negative out in front, that is called a reflection. And it's a reflection over the x-axis. So we're going to look at 2 parent functions. We're going to look at absolute value, and we're going to look at quadratic. And those are the two you need to be familiar with. So let's look at absolute value first. All right, so absolute value. So let's look at this one. So we multiplied by 2. This is like our example. But first I'm going to draw the parent function. So that has a slope of up 1 over 1. So we use the calculator to do this. But I'm going to show you how to do it by hand. So this 2 is changing the rate of change here. So the rate of change here is 1 over 1. Now it's going to be 2 over 1. So up 2 over 1. Up 2 over 1. Okay? And then you can see that this is a stretch by 2. And then this one, of course, is our parent function. Okay, let's try another one. So now we have 1/2, so it's a fraction and it's less than 1, so that means it's going to become wider. It's going to be a compression. So I know right away this is a compression by 1/2. So I'll draw my parent function first. Okay. And then I'll draw my compression, up 1 over 2, up 1 over 2. Up 1 over 2. So here's my compression. Let's do another one. Pause the video and try this one on your own. Okay, so this is going to be a stretch by 4. There's my parent function. Then I'm going to go up 4 over 1. 1, 2, 3, 4 over 1. Okay. And there it is. And then last one, pause the video, try this one on your own. There's my parent function for my guide. And then this is going to be a compression by 2/3. So up 2 over 3. So it's this one on the bottom there. Okay, so that's absolute value. Let's look at some quadratics. Okay, so first I want to graph the parent function. So a quadratic equation graphs as a parabola, that's that U shape. But to be accurate, to plot this accurately, I could make a chart, an XY chart here, and I'll plug in, say, 0, 1, and 2. Okay, so if I plug in 0, and for x, 0 squared is 0. So I know the point 0, 0 is on the graph. If I plug in 1, 1 squared is 1, so the point 1, 1 is on the graph. Plug in 2, 2 squared is 4, so the point 2, 4 is on the graph. Okay, and then I can reflect that over to the other side. And I have my parabola. All right, now, notice this is not a straight slope. Like on the absolute value was up 1 over 1, up 1 over 1. This one is not. This is a curve. The parabola is a U shape, so I can't do that trick with this one. I have to take my outputs, my y values, and multiply them by 3. I'm changing this by 3. And this is going to be a stretch because I know that's a whole number greater than 1. So when I multiply by 3, I do 0 times 3 is 0, so that doesn't change. 1 times 3 is 3, and 4 times 3 is 12. So those are my new points. So 0, 0 stayed the same. Now I'm going to plot 1, 3. 1, 1, 2, 3. Then I'll reflect that over here. Okay, and then 2, 12. 1, 2, up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Maybe somewhere up here. Okay, and then that would be my parabola. Okay, let's try another one. Okay, remember, quadratic parent function, the points are 0, 0, then 1 squared is 1, 2 squared is 4. 2, 1, 2, 3, 4. All right, so there's my parent function. Now I want to transform it by 1/4, and this is going to be a compression, so it's going to get compressed, or it's going to get fatter, wider. Okay. So again, I'm going to multiply my y, multiply by 1/4. Okay, 0 times 1/4 is 0. 1 times 1/4 is 1/4. And 4 times 1/4 is 1. 4 over 4 is 1. So then I plot those points. So 1, 1/4. And 2, 2, 1. So you can see how it's getting wider there. Okay. So to plot the new graph, the transformation, you're taking your x and then your new y, and that becomes your ordered pair. Those would be, that's what I just graphed here. Whatever you do one side, it's symmetrical on the other side, so you just copy that over to the other side. Okay, let's do another one. Okay, one more. So this is going to be another compression. And then I also notice this negative here, which means it's going to be reflected across the x-axis. So it's going to open down. Reflection. Okay. So let's graph the parent function. 0, 0, 1, 1, 2, 4. 2, 3, 4. There's my parent function. Okay. Then I'm going to multiply the y value by 1/2. So 0, 1/2, 4 times 1/2 is 2. So these are my new points. However, it needs to open down. So instead of going 1 and then up 1/2, you're going to go 1 and then down 1/2. And go 2 and then down 2. Okay, so it's getting wider. And it's also opening down. All right, I hope that was helpful. Let's do a few more examples. Describe how the following equations compare to the parent function y equals x squared. So where this is just explaining it in words instead of graphing it. So I see that there's a 4 in front, so it's the quadratic is being multiplied by 4. So that means it's going to be a stretch by 4. And that's all you would have to do there. So this one would be a compression by 2/3. And this one is going to be a reflection over the x-axis. And then this one is going to be a compression by 4/5, and that's an and sign there, and a reflection over the x-axis. Last one, finally. Okay, this is one of those trick ones. 5/4, that's the same as saying 1 1/4. So it is a fraction, but it's greater than 1. So that is a stretch. Stretch by 5/4. All right. So now I'd like you to complete the worksheet that is included under your assignment and then turn that in.